So let's look at these different graphs and let's see if we can match these graphs up. And I have an assignment for you guys in class to match these graphs up with what they look like. So a couple of things I see. I see one of these with a missing point. So what I think is that's a parabola with a missing point. So I think that's a cubic function on top divided by a linear function on the bottom. So I know it's that, and it's something that can be made into a quadratic for the linear function not equaling 0. So I see that right now. So where do we have a cubic function on top? Oh, it's right here. So here's a cubic function on top. Let's see, is 1 a factor of this? So we wouldn't have a vertical asymptote, we would have a missing point at 1. So let's see if that would work. So let's see, 1 plus 2 minus 6 plus 3. 1 plus 2 is 3 minus 6 plus 3. Yep, that would be 0. So this would be this number. So this, I'm going to call this A. This is A. So let's call this one B. So let's look at that B. We have a couple things. We have a horizontal asymptote at 0. So we have a horizontal asymptote, y equals 0. We seem to have a vertical asymptote at x equals -1. So we know we have x plus 1 on the bottom. And on the top, I should have something that's less than x plus 1. So I need a constant on the top. So where do I have a constant on the top and an x plus 1 on the bottom? Well, this is the only one that has an x plus 1 on the bottom is right here. So now let's look at this one. Let's look at our asymptote. So I have an asymptote at x equals 1. So, excuse me, a vertical asymptote at x equals 1. And a horizontal asymptote, it appears, at y equals 2. So what I want is I need x minus 1 on the bottom, and on the top I have something with 2x. So what does that look like? X minus 1 on the bottom, but that has a square at the top. That should have 2 asymptotes, so it must be this one. So let's call this one D. So let's see what this one, whoa, this one's funny looking. So it looks like it still has an asymptote. Even it can cross a horizontal asymptote, but it still goes toward it as we go off to negative infinity. Looks like we have a horizontal asymptote at y equals 0. And we have a vertical asymptote. Looks like we have one here at -1 and +1. So x equals 1, x equals -1. So that means we have some kind of like x squared minus 1 on the bottom. And then our numerator is something with x, or a constant. So something less than x squared. So let's see what that one is. So the only one with x squared minus 1 is this one. So that must be that one. So now let's look at this one, E. So this one says we've got a vertical asymptote at x equals 1, and we have a slant asymptote on that. So what that tells me is that we have x minus 1 in the denominator, and then we have a numerator which is 1 degree higher. So we have a numerator that has an x squared on it. So where do we have x minus 1 with, and there it is, right here, E. So now let's look at this one. Looks like we have 2 horizontal or sorry, vertical asymptotes. We have x equals 2 and x equals 5. So x minus 2, x minus 5. So it looks like our denominator would be x squared minus 2x minus 7, that'd be 7, plus 10. And we have a horizontal asymptote at y equals 0. So that means so this is our denominator. So our numerator is either a constant or an x. And here it is. So that's graph F. So that's how you can match these guys up fairly easily. And you can work from this level up to here, or you can work from the graph. So you have an assignment like that we're going to work on also in class. And that's about it. So I will see everybody in class. We'll do some more examples, of course, in class.